Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad, India. In this session, we are going to study the centroid of symmetrical sections. Let us recapitulate what is center of gravity, what is centroid. The center of gravity is the point, assumed point of the orientation of the whole weight of the body. So, the center of gravity is denoted by the letters CZ or G. And centroid, the point at which the total area of the plane figures such as triangle, rectangles, parallelogram, circle, etc. is assumed to be concentrated, is known as the centroid. And the center of mass means the entire mass of the body is passing to the one point, orientation concentrated at one point, is known as the center of the mass of the body. So the body may be having different shapes. It can become simple, direct simple figures or composite figures. The simple figures is nothing but the circle, suppose the simple figure, and is the rectangle or square is a simple figure, or is the rectangle, the simple figure. The combination of these sections is known as the composite figures. The circle, the two rectangles is the composite, and the triangle is connected at the bottom of the pot. The triangle is connected here, all right. Then this figure is known as the composite figure. So how to find out the various centroids of various sections? We can see here the shape of the section. Here it is the rectangle. The rectangle width is the b and height is h. The parallel axis, the reference axis, here x and y are the reference axis. The reference axis, the area of this rectangle, it is the b into b times h, bh, and x bar or x bar, bar x, the bar x equal to the b by 2. The centroid is the position, is the position of the centroid. And the centroid here, the centroidal point, we need the coordinates. The bar x is the b by 2 and the bar y, it is the h by 2. The bar h and the bar y. And if you consider the triangle, the base is the b and the height is the h. It is symmetrical about axis y. So the axis y, and it is on this axis, the bar x equal to 0 because the same axis on that only. Whatever bar y, the bar y, it is the h by 3 from the base. It is the h by 3. It is from the base. And from the point of here, the top point, that point it is becomes 2h by 3. And if we consider the circle, it is symmetrical about both x-axis and y-axis. It is at the center. So bar x equal to 0 and bar y equal to 0. Provided here the reference axis are x and y. Alright, the bar x and bar y. So these are the simple plane figures. In the previous session, we have studied what are the symmetrical axis and symmetrical. What is symmetrical axis and unsymmetrical sections? Symmetrical section, symmetry about axis y, and symmetry about axis x, and unsymmetrical about axis x, and unsymmetrical about axis y. So these are asymmetrical axes. But here we can see some more centroids or some more figures, the plane figures, planes. Here it is indicating the centroid. The centroid of it is bar x and bar y. It is, we need the point is denoted with the coordinate point bar x and bar y. So in this rectangular area, we can see here it is the point C is the centroid, and this point C here it is the vertical distance is a by 2 and horizontal distance is b by 2. That is the b by 2 comma a by 2 is the centroidal point of C for rectangular area in this figure. And here is the triangle area. The triangle area point C is, it is the bar. What about bar x? The bar x is the b plus 2a by 3 and bar y is h by 3. And you can see here trapezoidal area. The trapezoidal area bar x is L by 3 times a plus 2b by a plus b. And bar y is the of 1 by 3 times a square plus ab plus b square by a plus b. This is the trapezoidal area. How to find out this trapezoidal area centroid is the combination of a rectangle and the triangle. Is the combination. Is the triangle and the bottom part is rectangle. So we'll find out. We'll see in the coming sessions how to find out by using the bar x equal to a1 x1 plus a2 x2 by a1 plus a2, and the bar y equal to a1 y1 plus a2 y2 by a1 plus a2. What about a1 a2 are? A1 a2 are area of the section 1 and a2 is area of section 2, and y1 y2 is the distance, the centroidal distance, vertical distance of the section 1 from the reference axis, and y2 is the central distance of section 2 from the horizontal reference axis. And similarly, x1 x2 are horizontal distance from vertical reference axis. All right, and another one is circular area. The circular area of centroid is at the distance of r, and it is at the center 0 0, and the area of for that circular section equal to pi r square, or area of the circle in terms of the diameter, it is a pi d square by 4. And symmetry, the area of the rectangle area is a equal to a times b, that is the length and breadth, and area of triangle area half of base into height, that is half a plus b times h, and area of trapezoidal area is half of a plus b times l, length. All right, a plus b times l. And if we consider the semicircular area, here arc portion, the semicircular area of semicircle is half of the area of the circle, that is pi r square by 2, pi r square by 2. And what about centroidal area? It is symmetrical about axis y. It is on that axis. So bar x equal to 0. What about bar y? 4r by 3 pi. Is the quarter circle area. The quarter circle area, that is means 1 by 4 times area of the circle pi r square. And what about centroidal portion? The centroidal portion is 4r by 3 pi and 4r by 3 pi, bar x and bar y are. And if you consider the circular sector, the area of the circular sector is theta r square. And what about the centroidal? It is the horizontal distance. It is symmetrical about x-axis. So bar y equal to 0 and bar x equal to 2r sine theta by 3 theta. 2r sine theta by 3 theta. So these are, we learn here what is circular area, semicircle, quarter circle, and circular sector. Next, coming to elliptical area portion, elliptical zone. What is the ellipse? The elliptical area of centroid is symmetrical about both axis, x-axis and y-axis, and it is at the center 0 0, bar x equal to 0, bar y equal to 0, and this area A equal to pi AB. And coming to semi-elliptical area, half of the pi AB, that is pi AB by 2. What about here? 4b by 3 pi, but it is symmetrical about bar y, that means bar x equal to 0, bar y equal to 4/3 of b by 3 pi, b by pi. And quarter elliptical area, for the quarter elliptical area there is 1 by 4th of ellipse, that is pi AB by 4. And what about here the centroidal? The central portion is 4a by 3 pi and 4b by 3 pi, bar x and bar y. The bar x equal to 4a by 3 pi for quarter elliptical area, bar y equal to 4b by 3 pi. Next, general spandrel. In the case of general spandrel, the area of general spandrel is ah by n plus 1, and centroid here the c. The c is n plus 1 by 4n plus 2 times h, and bar x equal to, that is n plus 1 by n plus 2 times b, bar y equal to n plus 1 by 4n plus 2 times h. So these are the important centroids, geometries or planes, centroids and total areas we mentioned here. So these are the important plane figures, so that we can remember and also understand better. So these values, these formulae are these expressions are important for calculating the centroids of composite figures or composite planes. Okay, here number of times repeatedly it is symmetrical about axis x and symmetrical about axis y. And what is that symmetry about? Consider here in this figure the line having it is symmetrical about what is symmetrical about? Symmetrical about vertical axis, symmetrical about y axis, and it is asymmetrical, that means unsymmetrical about bar x axis, unsymmetrical or asymmetrical about bar x axis. How it is? If you fold about vertical axis vertically, it's the left side and right side, the geometry is same, the area is same, area of geometry is same. That's why it is symmetrical about it is symmetrical about y-axis. So in this y-axis, that means this y-axis becomes the reference axis. That axis becomes a reference. So it is the reference axis vertical. What about bar x value? Bar x equal to 0. And it is the horizontal axis, the horizontal axis. What about the distance of the centroid? If you fold about x-axis, suppose if you fold this figure, the plane, it will be, suppose it will be folded like that. And because then if we understand, is this geometry area geometry symmetry area geometry area geometrical area similar at the top and bottom? No, that's why it is asymmetrical about x-axis. Then it is not the centroid axis. Then we have to consider the reference axis. This is the reference axis. So bar y can't be 0 because vertical distance. Bar x equal to 0, it is symmetrical about axis y. That means bar x equal to 0. So thus we have, that is the concept of symmetry and asymmetry. Next, to go for next figure. These are the certain natural figures. It is symmetrical about what? Y-axis. Symmetrical. And bar x equal to 0. For all these figures, bar x equal to 0. This is the reference axis. What about bar y? The bar y is not equal to 0 because it is not symmetrical about horizontal axis. So it is symmetrical about x-axis. This figure, the leaf is symmetrical about axis y, and the bug also symmetrical about axis y. For all these axes, the bar x equal to 0 because these are the axes are symmetrical, reference axis. So beautiful. If we consider the lion or tiger or giraffe faces, all these faces, geometry, if you draw about vertical axis, it's symmetrical about axis y. So it's such a beautiful. Alright. So these are the certain geometries having lines of symmetry. There are various lines of symmetry. It can become single line of symmetry, one symmetry, and one line of symmetry and two lines of symmetry. Here, if we consider the above figures, if we consider these figures, these are all single line of symmetries, and including a line also, here also single line of symmetry. Alright. And these are the figures of single lines of symmetry. And some other figures are having multi lines of symmetry, two lines of symmetry also. If you consider the square is symmetry about axis x and the axis y. There are two, and one more diagonally also symmetry. This diagonally, that's why it is the four lines of symmetry, the square. And if you consider the rectangle doesn't have this facility. Okay, yes, if you consider it, it is not symmetrical about that's why it is the two lines of symmetry. What are the two lines of symmetry? About y-axis, axis y, and axis x. There are two lines of symmetry. That's why rectangle is a plane of two lines of symmetry, whereas the square is a symmetry, four lines of symmetry. And coming to rhombus, the rhombus is having two lines of symmetry. The bar is the y-axis, about vertical axis, about horizontal axis. It is the two lines of symmetry geometry. And if you consider the kite having one line of symmetry about y-axis y, vertical axis. What about horizontal axis? If you fold it, it is not symmetrical. That's why it is a single line of symmetry. Coming to trapezoid, isosceles trapezoid, it is only one line of symmetry. And what about horizontal axis? No. That's why it is a single, one line of symmetry. Coming to trapezoid, the trapezoid is here. This trapezoid having no lines of symmetry. That's why it is asymmetrical geometry. So if you make it vertical axis, make it horizontal axis, no. It is asymmetrical both axis y and axis x. That's why no lines of symmetry. So we discuss more about no lines of symmetries and we solve it also. We solve the problems. And here it is the parallelogram. The parallelogram is having no lines of symmetry. Why no lines of symmetry? If you fold y-axis, vertical axis, and if you fold horizontal axis, no lines of symmetry. Alright, it is asymmetrical geometry. And one more thing, equilateral triangle. The equilateral triangle is having 3 lines of symmetry. If you carefully measure, what is the 3 lines of symmetry? If you consider here, this is the vertical axis, one symmetry. The second is the 1, 2, and this is 3. That's why it is the 3 lines of symmetry geometry. This figure is. And coming to isosceles triangle, the isosceles triangle having single line of symmetry, one line of symmetry. Why it is about vertical axis. By horizontal axis, if you fold, it is asymmetrical about x-axis, horizontal axis. Alright, x-axis is asymmetrical. Okay, is asymmetrical about horizontal axis. Okay, and that means here in these figures, how many are there? There are 2 figures are there. It is asymmetrical. One is trapezoid, another one is parallelogram. No lines of symmetry. And the 4 lines of symmetry, only one figure, that is the square, is having facility of the 4 lines of symmetry. And the single line of symmetry figures are kite and isosceles trapezoid and isosceles triangle. And there are 2 figures in this plane figures. There are 2 lines of symmetry, both axis x and axis y. That facility is having. One is that rectangle and another one is the rhombus. Now, the trapezoid and parallelogram are considered as asymmetrical geometries, asymmetrical sections. Asymmetrical means unsymmetrical, whereas remaining are symmetrical sections because it is either about axis y or axis x. All right. Now, very simple, beautiful example of what is symmetric, what is asymmetric. It is symmetric about axis y. It is symmetric. At least one line of symmetry is known as symmetrical sections. And it is not symmetry about axis y, neither axis y nor axis x. Then it is known as asymmetrical sections. Alright. In this figure, it is the asymmetric axis y and also axis x. Alright. If you fold, very simple concept and beautiful. Now it is symmetrical about axis y. That's why it is a symmetric section. It is symmetric geometry. Alright. I hope you understood better. Now, what is the symmetric shape? A symmetrical shape definition is a shape when divided down, the middle is the same on both sides, then it is known as a symmetric shape. And asymmetric shape, a shape when divided down, the middle is different on each side. When divided down the middle, it is not similar, then is known as asymmetrical shape. And symmetrical shape is when divided down the middle portion when is same. A shape when divided down, that is the same on both sides. Left hand side from my side and this side right hand side from my side. Then it is known as symmetrical section, symmetrical shapes. Alright. I hope you understood better what is symmetrical and asymmetrical shapes and asymmetrical sections. Alright. Now, coming to solve what is the centroid of the section. Now find the centroid of 100 millimeters by 150 millimeters and 30 millimeters. 100 millimeters the wide, 150 millimeters here and 30 millimeters is the thickness. Here we consider the T section. Here the T section, it is symmetrical about, come on, what is symmetrical about? Axis y, vertical axis. That means bar x equal to 0. What to be calculated? Bar y. What is the bar y? A1 y1 plus A2 y2. There are 2 sections are there. by A1 plus A2. Substitute. What is the A1 here? Area of the section 1. The area of the section 1 here, it is considered, yeah, section 1. That is ABCH. Is the area of section 1, and it is the section 2. Alright. So what is A1 here? A1. A1 here, it is the, okay, it is the flange. This portion is known as the flange, and here this portion is known as the web. Okay. But here the A1, area of the section 1, that is length, a rectangle, length into breadth, that is 100 into 30 millimeters, that is 3000 square millimeters. What about Y1? What about Y1? The reference axis considered as F is the reference axis. This is the centroid of section 1. Centroid of section 1. From the center, the distance Y1 is the distance from the centroid of the section 1 to reference axis. And is the centroid of section 2, the Y2, that becomes 2 where the reference axis, that is the Y2. Y1 means from here to here up to H to F. What is the H to F? 150 minus 30, that becomes 120. 150 minus 30, that is 120, plus 30 by 2, that becomes 120 plus 30 by 2, that is 120 plus 30 by 2, 15, and that is 135 millimeter. Y1 equal to 150 minus 30 by 2, or this total distance is 150 minus 30 by 2, that is the distance Y1. Y1 is the distance of centroid of a particular section to the reference axis, vertical distance. Now next, rectangle, another rectangle is the GF, that is DEFG, DEFG. It is a rectangle, that is A2, that is 120 times, this is 120 is the length, and the width is 30, 120 times 30, that is 3600 square millimeter. Then what about Y2? The Y2 equal to 120 by 2. Why it is becomes 120 by 2? The distance is the rectangle, length is 120, 120 by 2. That is the distance of centroid to the reference axis, 120 by 2. That is 60 millimeters. We know A1, A2, Y1, Y2. And what is the bar Y? Okay, bar X equal to 0, as I said, bar Y equal to A1, Y1 plus A2, Y2 by A1 plus A2. Substitute A1, Y1 and A2, Y2, then we get the answer. The obtained answer is 94.1 millimeters. So these are symmetrical sections, centroid. It is symmetrical about either one of the axes, either axis Y or axis X. Alright, those are called as symmetrical sections. So we consider here the symmetrical sections of the geometry, the T section we considered, and the calculated the bar Y. Suppose if we consider the tilted T, the tilted T having it is 30 millimeters, and here it is 100 millimeters, and the length of here it is 150 millimeter, and here it is 30 millimeters. How to solve the bar X and bar Y? Now let us begin. It is a symmetric about which axis? As symmetrical about axis Y. The symmetrical about axis Y, that means bar X equal to 0. What to be found? And consider it is section 1 and it is section 2. And how to find out? And what about these distances? We'll use the plane, light planes. Yes, the distance of this portion is 150 minus 30, that is 120 millimeters. So, and here it is A1 100, A1 equal to 100 by 30, 100 into 30, and A2 equal to 120 times 30. Okay. Now what is required here? Bar X equal to 0. It is symmetrical about axis Y. That means bar X equal to 0. And here it is the reference axis we are considering. We need vertical distances. Is the centroid, that is X1, that is 30 by 2. That is Y1 equal to 30 by 2. What about Y2? The distance of centroid of section 2 to the reference axis. What is the Y2 equal to? That is 30 plus, you can say directly 30 plus 120 by 2. that is 30 plus 120 by 260, that is 90 millimeters y2. Y1 equal to 15 millimeters. Alright. What about A1? A1, area of the section 1, that is 100 by 30, that is 3000. And A2, what is the A2? Area of the section 2, 120 by 30, that is 360, 36, yes, 36, 3600 square millimeters. Alright, now substitute in the formula of A1 Y1 plus A2 Y2 by A1 plus A2. That is the bar Y comes. Because bar x equal to 0 is symmetrical about axis Y, bar x equal to 0. And here the reference axis, these two are reference axis. Now bar Y comes, Y bar Y equal to A1 Y1. What is A1? 3000 times Y1. What is that Y1 value? Y1 equal to 15. Plus A2 Y2. What is the area of 2? 3600 times Y2. What is that Y2 meaning is 90 millimeters by A1 plus A2, or 3000 plus 3600. So you calculate bar Y value when it is the tilted T section. Okay, if we calculate the bar Y value, it is entirely different from the value we consider the T section. For this T section, it is different from this T section. You'll get it. Alright. So thus, this is the method of calculating the centroid of the plane figures. So what is here the values you can calculate bar Y. Similarly, for the sections, you can also calculate as an assignment of the left hand side, the symmetrical about which axis, horizontal axis, and you can also find out the T sections when it is horizontal T section. Now, how to solve the case 1? Now, here it is, that is really close. Symmetrical sections, here one of the symmetrical section. You can practice the problems. Okay. It is symmetrical about which axis? Horizontal axis. Horizontal axis means what about bar Y, vertical distance? Bar Y equal to 0 for both the things, for both the sections. What about bar X? The section 1, section 2, geometry, make it. Now here 1, now what is that? A1, Y1, then bar X equal to, what happened now? A1, X1 plus A2, X2 by A1 plus A2. What is the area of section 1? Suppose here it is mentioned 100 millimeters and here it is 30 millimeter. Alright, now here it is 150 millimeters total. Whatever this distance become, and it is 30, as I told you 30, and it becomes how much? 150 minus 30, this is 120 millimeters. What about A1? A1 equal to 100 times 30. For this case, A1 equal to, yes. What about A2? A2 equal to 120 times 30. And next one, what is X1? What about X1? Centroid of section 1. Which one reference axis now? You consider this the reference axis of vertical reference axis, because it is a horizontal reference axis that is passing through. It is a symmetrical about which axis? Horizontal axis. So bar Y equal to 0. Now what about X1? The X1 is 30 by 2. What about X2? 30 plus 120 by 2. 30 plus 120 by 2. That is 90 millimeters. And here it is 15 millimeters. Substitute A1, A2 and X1, X2 in bar X formula, then expression. Then we'll get it the horizontal distance of centroid. It is on this horizontal axis. We need horizontal, where it will be. Similarly, same thing, same dimensions. This is 100 millimeters, and it is 30, and it is 30 millimeter, and here it is, you mentioned here it is 120 millimeters. Can you apply the formula of the same methodology? Bar X equal to A1. It is symmetrical about horizontal axis, so bar Y equal to 0. And what is the bar X value? A1 X1 plus A2 X2 by A1 plus A2. So This is the T section. The same methodology will apply for various sections, I sections, and different sections. You can apply that to calculation, how to calculate the centroid of a symmetrical sections. All right. It is symmetrical about which axis? Bar Y, we consider two cases, and symmetrical about x-axis. Consider here the two cases, that is the horizontal T section. All right. This in this manner we have to calculate, or we can calculate, or centroid is to be calculated by using the expression of bar x and bar y. All right. In this session we covered again what is symmetrical, what is the centroid of various sections, centroids of rectangle, centroid of trapezoid, parallelogram, isosceles triangle, okay, rhombus, plane figures, what are the expressions for those planes, and also what is the methodology, what is the symmetrical section and what are the asymmetrical sections. And finally we solved there are four cases. It is symmetrical sections of T section, it's symmetry about axis y for two cases, vertical T section and downward top C, that is inverted T section, and the horizontal T sections, left side horizontal and right side also. The four cases we solved how to solve the centroid of T section. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.